All right, so today the focus of the webinar is to use the randomness feature that is built into most computer languages and show how it can help in a specific game and add some difficulty to the game. So that's what we're going to try to do here. So first, since we're doing with, I've been showing the things with Greenfoot, that's all in terms of Java. So I will basically show how Java handles randomness as well, and maybe at least give you an idea of how it's handled in other languages as well. So in Java, the main randomness function comes in the math class, and it's a method that I'll just show. R equals math dot random. Okay, so basically what math dot random does, let me show it first. I'm just going to print R. So this is not in terms of a game or anything like that yet. Just giving you some background on what the randomness method does. So if I run that, here's what math 0.667 with a bunch of decimal places, maybe like 15 decimal places or something like that. And you can kind of think of it as each digit is a random digit from 0 to 9, so 10 digits. Okay, so there's no zeros in here, but there definitely can be, just didn't happen at random. So the very lowest theoretical random number that you could get would be if you randomly got all zeros. Now, obviously, that's unlikely to happen, but it is possible to happen. And the highest decimal that you could get, or the highest number you could get from math.random, would be if you had all nines. So the range for math.random is any double between 0 and 1, including 0 and 1. So it'll look something like that. In notation. Anything including 0 but not including 1. So if you ran it again, just to show, I get an idea. Like I said, each digit essentially is a random digit from 0 to 1. There's always going to be a 0 there. So that's the range. Okay, so a couple things you can do. I'll kind of show the one way you can use randomness is to use random integers. So for example, if you were to roll a die, which is singular for a pair of dice, so it would be one die. If you were to roll a die, and you would either get a number from 1 to 6. So if you think about, well, it looks kind of weird to say die there, but int die is equal to. So if you threw the math.random there, that gives you a number in between 0 and 1. It does not give you 1, right? And if you multiplied that by 6, then if you think about the range, I'll show it here. That's essentially that range. Okay? So that's essentially that range, anything from 0 to 6. But since you can't get 1 here, you can't get 6 right now. Okay, you could get 5.3, you could get 4.6, with a bunch of decimal places after that. Anything between 0 and 6, not including 6. So since we want just integers, and essentially just 1, 2, 3, 4, 5, and 6, we can cast this expression to an integer, which just means kind of make it become an integer. Now, what that does, though, if you think, well, how do you make 5.3 into an integer? Well, usually in Java it's definitely like this, and in most languages work the same way. It just truncates the decimal. It just chops it off. So 5.352 just becomes 5. So it's not a rounding up or down feature, it's just a rounding down feature. And the decimals just go away. So if I had this right now, let's think about what it would be. Any number in between 0 and 1 would go down to 0. And any number in between 1 and 2 would go to 1, and not including 2, right? It would go down to 2. So then basically we can get 0, we can get 1. We can get 2, 3, 4, and 5. We can't get 6. Okay, so in a die, it's pretty easy. We just want that plus 1. Right, and now that can take on any number in between 1 and 6. Okay, and just to show that, let's put this in a for loop. And we haven't done, or I haven't done a ton of stuff in the for loop with the games, but let's just say that this, just understand that this gets this to happen 1,000 times. Okay. And every time I'm just going to print out the result. Okay. So every time I get a random number from 1 to 6, and then I print that number. Essentially, I'm going to get 1,000 numbers, and they should be just random numbers from 1 to 6. Okay, so it looks like they all pop up kind of, about this randomly, like we would expect. We would not know until we did, some math behind it to see kind of how often it comes up, to make sure one's not coming up more often than the other one. So before we get into the Greenfoot, to kind of translate this over to Greenfoot and how we can use it, let me just do this to be 2. Okay, so now it's a coin, or just think of a coin that's equally likely to happen. So heads and tails. So if you math out random, gives you a number between 0 and 1 that not 1. You multiply that by 2, you get any decimal between 0 and 2, not including 2. So now if you cast that to an integer, you get any integer that's either 0 or 1. Remember, you can't get 2. And then if you add 1 to that, you either get 1 or 2. So now, instead of having 6 options, we have 2 options, and you can see that was a pretty easy transition if you're talking about random integers, to go from the random method of the math class to that. Okay, so what I'm going to do here, instead of printing it out every time, I'm going to create a count variable. So int count equals 0. So what count is going to represent is just, it's going to keep track of how many times I got a heads. I'll let heads be 1 and tails be 2. So every time I go through this loop, which again iterates or loops through 1,000 times, I'm going to see if the coin is equal to 1, which is going to be my heads count. Okay, and I'm going to do count plus plus. Okay, and so at the end of this loop, this will happen 1,000 times. At the end of this, if I printed out count, as opposed to just printing out the result every time, I should get an idea of how many times heads occurred. So theoretically, if you flipped the coin 1,000 times, you would get 500 heads. Now this is random, so we don't expect to get necessarily 500. There's 507. Okay, so out of the 1,000 times, we got 507 heads. Do it again. We got 513. Okay, so those are pretty close to the theoretical 50%. And if you divide count by 1,000, you would get the percentage, because 513 might sound like a lot, like it's 13 off. Really, 513 out of 1,000 is 51%, and this is 0.517. So that gets theoretically closer, or it will get closer to the theoretical value. And if you weren't convinced, you could get this to iterate 100,000 times, which you might think would take this compiler a while to do it. It does not. Okay, 0.49955. So obviously it's getting convergent to 50%. Okay, so that's just a little bit of background about the specifically math of how it works, which is pretty similar to the other languages. Usually you can think of, at least at the base level, you will get a random decimal between 0 and 1. Now, people have written methods to, get like a random integer, kind of what we did here. But that's at least at the base, random decimal from 0 to 1, pretty much with all of them. Okay, so to show you a couple of ways you could use this in Greenfoot, I still have the blackjack class here, and I guess I can just use it on this board. There's nothing in particular about this. Well, actually, let's just create a new scenario. I'll just call it randomness. So I will show the concept similar to what we just did, and another concept that you can use with math.random. Okay, so let me first make sure I have a little some kind of background, doesn't matter what it is. Okay, and I'll create an actor, which is just going to be dot. I'll just call it dot. That'll work right there. Let's see, get a different color. All right, so I'll do that one. So right now I just have this world, and I have this dot object that I can put in. Okay, so the two things that I'm going to do with this game, essentially, is I'm going to use the math.random method to, number one, put the dot at a random location, random x and a random y coordinate. Remember, this is 600 pixels by 400 pixels. Remember, the top row and the bottom row would be 399. So I'm going to use that random. I'm also going to do a random method to, which is used a lot of times in games. Use a random method to kind of associate a probability to an event. So I'm going to make the act method call every now and then at random, put a random dot in the world. Okay, so basically think of it like an enemy, and you can randomly spawn an enemy. You don't want it to always, for a player to know exactly when the next enemy is going to come up. It should be kind of random, so it's different every time. So that's basically what I want to show here, and I will go to the world class. Okay, so I'm not going to do anything in the constructor. So that means whenever my world gets created, there are no dots in the world. But I'm going to create this public void act method, which, remember, act gets called continually whenever you click the run button. So act gets called continually whenever you click the run button. So basically, I will do, every time act is called, I'm going to do double R equals math.random. So we know that gives me a number between 0 and 1, not including. So depending on how often I want this to occur, I can associate a probability with it if R is less than 0.1. So if we stop and think about that before we get on to the adding it to the world, how often should R be less than 0.1? So it should happen about 10% of the time. So there's a 10% chance every time act is called that it adds a dot to the world. And we can make that smaller if we need to, because remember, at the standard speed, act gets called 50 times a second. So if it gets called 50 times a second, it might be spawning several dots a second, even with this random condition. So you'd have to make it more strict if you want it to occur less often. But we'll do that. We'll just kind of see what we want. Okay. So this is one way you can use math.random to associate some kind of probability with an event, if you don't want it to always occur at the same time. And the other thing we're going to do is int x equals, so again, start from the beginning like we did with the coins. I have math.random, random number between 0 and 1. If I multiply that by 600, That now gives me a decimal between 0 and 600, not including 600. Notice I'm getting an error because this is a decimal going to an int. Plus I don't have the semicolon. But so if I do the same thing we did before, multiply it by 600 first and cast it to an integer, this gives me a integer from 0 to 599. From 0 to 599 is what that would be. And that's essentially what I want. Because there is a row 0 in the world, there's not a row 600. Right? It would go from, or I guess X, and that'd be columns. But it would be from 0 to 599, which is what I want. And then, let me try Y equals. Okay. And then, again, this will only happen 10% of the time, but every time it does, I will get a random X and a random Y. And I will add a new dot to X and Y. Okay, so let's see what this looks like. So when I reset, nothing happens. When we hit run, coming in at random times, it's not uniform. But since act is happening 50 times a second, probably spawning more than we would need. So if you wanted to change that, you would need to make your probability less likely. So instead of maybe less than 0.1, if I change it to 0.05, it will happen about half of those. It's got half the chance. It's got a 5% chance now every time act is called. So you can see that they're a little less likely to pop up. And if I went down to 0.01, that would take it down to about a 1% chance every time. And again, we can kind of see how that looks. But now it's kind of more like what you would expect, just at random times. See, the third one came up kind of right after the second one. Sometimes it's a long time before the next one. Okay, so that is two different uses of a random feature. One, to use like a probabilistic idea of how often something should happen. And the other one is to create a random integer using math.random to associate to one specific integer, like in this case an X and a Y coordinate. Okay, and I'm sure there's other uses of randomness, but these are two good ones that you can use to get some kind of game going.